The University of Louisville Cardinal Steelworks team is proud to present our multi-tool for the 2026 Additive in Steel competition. After winning the competition in 2025, our goal this year was to improve upon the tool from last year without reusing the same tricks that made it stand out. The new tool will be assembled from multiple printed parts while maintaining the plier-like functionality of the original. We wanted to use the maximum allowed dimensions to give us more room to creatively add tools to meet the competition requirements. With our design finalized, we simulated many of the required functions of the multi-tool to determine our factor of safety for each feature. We used this to drive our final design choices as we prepared for the manufacturing of each component. After a few design iterations, we decided that our unique feature of the multi-tool would be a ratcheting mechanism for the 1/4-inch socket drive located in the hinge of the tool. Plastic prototypes were used to dial in the ratchet mechanism so it could be easily installed into the printed part. The geometry for the ratchet can print without supports, and everything fits perfectly into the hinge that was originally designed for the new multi-tool. Assembly of the multi-tool, including the seatbelt cutter, hinges for the handle tools, and a place holding both sides together, was to be done using directed energy deposition to weld everything together. The team set up the new multi-tool for laser powder bed fusion with materialized magics. Support generation was done manually to account for some design for additive manufacturing techniques used in the new tool, like lightweight latticing added to the ratcheting half of the tool. While keeping the 2025 multi-tool on our minds through the design process for this year's multi-tool, we decided that we had another use for last year's tool. Using Amist's Amazement atomization platform, we could recycle failed prints from last year's multi-tool to create powder feedstock for the new tool, essentially allowing us to build the new tool with the old one. The atomizer typically is used for melting refractory high-entropy alloys. The machine also acts as an alloy development platform, allowing researchers to use raw elemental materials to create new metal alloys, and then atomize those new alloys into feedstock for additive manufacturing systems. The old multi-tool is driven into a plasma torch, dripping molten stainless steel onto the sonotrode below. The atomizer uses ultrasonic vibrations to excite the pool of molten steel from last year's multi-tool, creating airborne droplets of steel that are carried away in a flow of argon gas. This creates spherical powder particles suitable for multiple additive manufacturing processes. The newly atomized powder is extremely spherical and has a larger, more uniform powder size distribution than the original material used to make the multi-tool. The material supply used in the original multi-tool has been reused for many years and is full of satellite particles and condensate that contaminate the powder supply after multiple uses. The new powder was mixed into this old feedstock for the final run of the multi-tool, so last year's multi-tool lives on in this iteration. With the help of the Amist Labs co-op students, the multi-tool was printed in the M280 multiple times to optimize support strategy and include new design changes. The hollow handles required stronger supports to withstand the residual stresses built up in the top surface of the part. Once this problem was solved, the parts were removed from the build plate using Amist's FANUC wire EDM. Witness specimens and tensile bars were printed with the final design of the multi-tool, and SEM images were taken to compare the element distribution of the final printed part to the newly atomized and original material. Assembly of the tool was done in the Beam Modulo 400 DED machine. Plates printed in the M280 were welded to the handles to hold everything together. The Cardinal Steelworks team is excited to use our multi-tool at the 2026 Additive in Steel competition. We would like to thank America Makes for hosting this competition and giving us the opportunity to compete.